Hey, welcome to today's video where we're going to be taking a look at this circuit board right here. It is the Rev B of the J1850 transceiver, the one that's emulating it. So it's not part of this project where we were using the data link chip to do it. This time we are emulating it similar to the Machina M2. Before we really dive into this, I just want to remind you this is Rev B, so we may not go over some of the same stuff we did in the Rev A video. You may want to check that out. I'll try to remember to link that as a card or put it down in the description. But yeah, this is Rev B. There is a Rev A of this. I've already sold out of Rev A. I'm not going to sell more of that one, but Rev B I will sell. I have plenty more of the boards to assemble, and I got 5 of them already assembled and ready to sell right now. All right, well, before we get too far into this video, let's take a quick look at a Rev A and a Rev B. Now, this Rev A is heavily modified. If you want to see what the Rev A's really look like, you'll have to check out the Rev A video. What we're looking at right here is the board that I used to first mock up the Rev B changes, test them before ordering the boards, and then I mocked up some changes that I needed for a development kit that I'm working on. So yeah, this is very heavily modified from a Rev A. It used to have a LDO right there. That's one of the changes. We got rid of the LDO and just went to using a transistor and Zener, mostly to save space to fit all of the stuff that I'll need to do for that one. I know I have a ton of spare space here, but I was trying to optimize here and then optimize even more for this mod that you'll see in a future video. But yeah, so one of the big changes is how the 7.5 volts is generated for the communication. We also added the wave shaping stuff that we tested out in Rev A in that video. So that's all incorporated now. So there's no more ringing. The ringing's gone in Rev B. And yeah, so all of these modifications and all of these components, there's a lot of suitable subs out there for it. So I'll be able to support this far into the future. This product here, we can only support it as long as these chips are still available coming out of China, but they're very long obsoleted. So eventually the chips are going to get too expensive to be able to support this. Now, I do plan to support this as long as I can, so don't worry, it's not going away anytime soon. I definitely know I have enough to support it for a few more years before this becomes the only thing that I'll be able to support for the J1850. I do have some other products coming out that y'all will like, doing like GM LAN and some other stuff too. So definitely keep an eye on the channel for other projects. But let's take a look at the schematic, get a little bit more of an idea of what's going on, and then we can set one up like so and actually do some communication with it. Okay, let's take a quick look at the schematic. We got Rev A pulled up here, and then on the other tab we have Rev B. So on the Rev A schematic, you'll notice we don't have that capacitance across the collector here, and we have a different resistor here, and then we also have this linear regulator here. Sure, I mean, this is just a linear regulator as well. We're just building it ourselves. The main reason for doing this was because it's actually smaller. It takes up less space with this configuration than it did with this configuration, mostly because of the extra components that go along with it, because it's this, the footprint of this and this is about the same, and then we only have one resistor. So we can fit all of those components in the exact same space as just this guy himself. So yeah, we saved a little bit of space on the board doing that. We have that wave shaping going on here at the collector to help keep us from ringing. And I also added a TVS diode to protect this and eliminated, there was a 10K resistor there, just eliminated that. So yeah, I mean, not a whole lot changed in the schematic, mostly just improvements we went over in the other video. We kind of already knew this was going to happen based on our last video. So yeah, same basic concept here. The pinout's still the same. I still didn't put a TVS diode across the 12 volts because I'm assuming you're going to condition this before it makes it there, because you have to make your own 5 volts on your project as well. So, you know, you probably are going to condition your 12 volts before you do that. So did not include that on the board, but I do include the TVS protection for the communication, because I'm assuming that this is going straight onto the comm bus in the vehicle. So, you know, yes, we need to provide it here on this board, because I am assuming you're just connecting this directly to communications, but I am not assuming that you're connecting directly to 12 volts. So, you know, just something to be aware of if you're designing around using this board on your project. If you're gonna put this board on there, make sure you're conditioning that 12 volts, so that way you don't, you know, burn up the linear regulator here. The higher the voltage is, the more power you're dissipating through that linear regulator. And I mean, this this guy definitely can support more than what was necessary, but there's not a ton of headroom here. So you will eventually break this if you don't condition that. So just something to be aware of. But yeah, no really major changes here. So if you want to know more about how this circuit's working, definitely check the Rev A video. Okay, so let's take a very quick look at the setup before we change the screen here, where you're going to see this, the oscilloscope and the computer monitor. What we're going to use is a Arduino Nano and our Rev B board. We're going to use it in transmit mode, since that's going to show us the most of the circuit working. I've already tested it. Transmit and receive do work. There's been no change to the code, so I'm not really going to get into the code for this at all in this video. You can check out the Rev A video if you want to know more about that. We have our older data link chip and an Arduino Pro Micro that we are using as our receive unit. So we'll just open this guy's firmware, send them the command for RX, and we'll just receive there. For our scope probes, channel 1 is on the receive line over here, so that way you can just get an idea of how that looks, and channel 2 is on the bus. Last video I did on these, I had a question about why the twisted pair, because this is not a differential signal, and that's true. It is not a differential signal, but we do still need ground connected. Obviously, I already have ground connected throughout with this right here. However, I went ahead and connected it as if it was in a system, because in the car you still do need a reference to ground. So yeah, so we have bus, ground, and the reason why they're twisted is just so it gets tangled. It's not because it's like a differential pair that needs to be a twisted pair wire. It's just to keep it organized on the bench. It's already a spaghetti mess with these little jumper wires that I use. No need to make it worse. But yeah, so on the Arduino, we really only need 2 pins for this. We need the RX and TX for this, and this isn't like your UART RX and TX. We define 2 pins in firmware as our RX and TX for this, and that's it for that. We have that fault pin that we could look at to see if we have low voltage on here. But yeah, other than that, it's a nice simple setup. Where we're getting our 12 volts is actually from the data link chip. It has that little boost converter right there. And then we have the jumper you can set right here to allow the 12 volt to come out. So yeah, set the jumper and we have the 12 volts coming out there, and then it jumps over here. So that's where we're getting our 12 volts to run this, is from this guy. And as I had pointed out in the product videos for this, you could also use that jumper to backfeed this and not use this boost converter. You could just take all those components off if for some reason you didn't want the boost converter, or if you were assembling this yourself and you knew your project already had 12 volts. So yeah, that's the overview of the setup. Let's actually get into it and take a look at it. So let's go ahead and get this set up and ready to run. We're going to start up the data link chip first. It's what builds our 12 volts that we're using over here as well. We'll go ahead and put this one in RX mode. So it's in RX mode. Let's go ahead and connect power here. And there we go. So we can see that both devices are running, and the data link chip's receiving, and this one's transmitting. And so yeah, you know, it is working, and you can see this triggering. And we're just sending the same frame over and over again. So as you can see, we've gotten rid of all of that ringing that we would see. Let's bring in the scale here. You know, we were seeing that huge spike on it, and that's now gone. Channel 2 is the bus, and channel 1 is the RX pin on here, so that way you can see what it looks like when it's receiving as well. Hopefully you found the video about these interesting. I know I didn't get into too much detail about it, but that's because a lot of this was covered in the previous video, and I do have another video coming up on these soon. That one's going to be more of a development kit to help you like get started doing something useful with these, because I've had a lot of people request, you know, like hey, help me get started with this project. And I don't have time to help everybody, but I could definitely make a kit that will help you get a little further along in your project. So definitely keep an eye out for that. And also I'm going to have another video here soon about this project, which is GM Land, the single wire CAN bus that GM used. The project, at least the circuit board's already working, tested. Right now I just don't have anything really interesting to put in that video, so I'm working on that right now, because all I could show is the two modules talking to each other, while with the class 2 stuff, the J1850 variable pulse width, I have all of those videos showing it doing, you know, instrument clusters and all sorts of other communication. So I want to do something a little more interesting than just the two modules talking to each other in the first one. So I'm going to try to get that set up where it's working with an instrument cluster. But yeah, so that's kind of what's going on with the channel right now. I also have another video for this guy right here, which was my last video. But I need to make the little hats that go on there. So I got the design done on those. It's just a matter of working out either sponsorship on that or just ordering the boards to get it done. So yeah, I got a lot of videos in the works. So if you haven't already, subscribe to the channel. It helps support the channel. If you're interested in buying one of these, the link's down in the description, and you can get them off my eBay. So yeah, I hope you guys liked the video, and I'll see you guys in the next one.